Hello, this is Dr. Benjamin Norris from the Chemistry Department at Frostburg State University. Today we're going to do some practice problems on applying thermodynamics to organic chemistry. Let's practice, using the bond dissociation energy data provided to estimate the change in enthalpy for the following reaction. The timer will give you 10 seconds. If you need longer than 10 seconds, feel free to pause the video. Remember, if you need more time, feel free to pause the video. First, we need to determine which bonds were formed and which bonds were broken. If you've worked out the problem, you might notice that I gave you more bond dissociation energy values than you actually need for this. This is going to be typical if you see this kind of problem on an assignment or an exam. You're going to have more information than you need to solve the problem. So we need to identify which bonds are being formed and which bonds are being broken. Two bonds are being broken. The carbon-oxygen bond in the alcohol and the hydrogen-chlorine bond in hydrogen chloride. The bond association energies for these are 381 and 431 kilojoules per mole, for a total of 812 kilojoules per mole. There are two bonds being formed, the carbon-chlorine bond in the alkyl chloride and the hydrogen-oxygen bond in water. And the bond association energies for those are 331 and 498 kilojoules per mole, for a total of 829 kilojoules per mole. And then, to estimate the change in enthalpy, we subtract the sum of the bonds formed from the bonds broken. Remember, it takes energy investment to break bonds, and energy is released by forming bonds. So 812 minus 829 is 17 kilojoules per mole, negative 17 kilojoules per mole. So this is a reaction that's slightly exothermic. Let's do another problem. Let's estimate the sign of the entropy change for that same reaction. In this case, I've also written out the reaction equation with the states of matter listed to help us make our determination. Remember, if 10 seconds isn't long enough, feel free to pause the video. Remember, if you need more time, feel free to pause the video. First, we need to start thinking about the factors that might lead to a change in entropy. There's no change, it's the same number of molecules on both sides, so there's no change in the number of molecules. There's no change in the number of sides of rings because neither the reactants or the products have any cyclic molecules in them. There are no multiple bonds anywhere in any of these structures. However, the reactant side has a gas, and there are only liquids in the product. So here's a change. Since we have one factor that suggests a decrease in entropy, we're going from having some gas in the reactants to no gases in the product. Entropy is probably decreasing. In our next video, we're going to talk about reaction energy coordinate diagrams and how to interpret them to understand organic chemistry reactions and mechanisms. Thank you for watching.